here, and let's move on now. We're going to think about the derivative. So let's give ourselves just a little bit more paper here just to work on, because we're going to take a few more notes. So derivative, we think slope. Slope, we think derivative. Derivative, we think slope. So what we're trying to find now is how to find the slope of an inverse function. Okay. So so let's see what we know about slope for a start. So slope is simply going to be rise over run. We go back always to basic principles here, basic ideas, algebra 1 stuff, this. But we're going to use probably a little bit of ideas from calculus. So if we're looking at f, we're really looking at a rise along the y-axis, a difference in the y value. So we'll say delta y, this is calculus sort of notation, divided by a run which would be delta x. But before we'd said that the inverse is just the opposite. So the inverse, we simply swap the x and the y. That's what we did. So we should then, so this is the slope of f. If we want now the slope of the inverse, and let's just use the same, let's just use colours here just to keep everything nice and easy, so we can identify stuff. Inverse f, slope of the inverse f is going to now be, the reciprocal of this. We're going to swap the x's and y's over. So now we're thinking that delta x over delta y. This is a sort of reciprocal situation. Well, not situation, but reciprocal. From here to here is a reciprocal. So this gives us a clue about finding the slope of an inverse function. So we can start to use a little bit of notation here. And we're going to try and keep the colours the same. So, inverse f, the slope, and we've used prime for slope, is going to have something to do. And I'm going to put an equal sign here at the moment because we're going somewhere. But for the moment, the equal sign is not really being accurately used. It's going to be 1 over the reciprocal of the slope of f. Well, the slope of f is f prime. So all I'm stating here is that the slope of the inverse f is going to have something to do with the reciprocal 1 over the slope of the original function f prime. Okay, let's go back to this. Here we've got an x coming in, and here f prime, inverse f. What's the slope, the instantaneous slope at this point? Well, we're drawing in a tangent line. Let's draw in a tangent line. And we can see at this point that the slope at this point is going to be roughly 2 over 4. So it's going to be roughly 1 over 2. Roughly, that's the instantaneous slope at that point. Well, if we go up here, there is no way is this slope the reciprocal of this slope. We've gone up from this value of x, so we can't put x in here and x in here, because the reciprocal at this value of x is the slope of, on the red line, the inverse, and on the black line, the original function. These slopes are not obviously reciprocals. I mean, actually, if anything, they're almost the same. But that may just be a coincidence. But what did we just look at? We said that if we come across here, input of x here, we get an output. Take that output of the inverse f, bring it in, make it the input for our original f, and we get the undoing process. Now, if we sketch in here a tangent line at this point, and then look at the slope here, we're getting 1, 2, 3, 4, 4 and a bit, 1, 2, 2 and a bit. So we're getting here a slope of f that very approximately is 1, 2, 3, 4, 5, 1, 2, 2.5. Well, we're getting a slope roughly of 2, or 2 over 1. Now then, 2 over 1 and 1 over 2, even with our rough sketch here, this is a rough sketch, these are reciprocal. So here we have the clue that in fact the slope of the inverse function is the reciprocal of the slope of the original function f, but where the input is the output from the inverse f. So what we're now able to do is to say that we can put an x in there because it's this x, and the input into our f is not x, but it is this inverse f of x. Now we've actually got something that we can work with. So the inverse, the slope, the derivative of the inverse of f at this x is going to be the reciprocal of the slope of f, the derivative of f, when the input to f is the output of the inverse of f. So we see that, and I'll try to keep the colours in to help us do that. One caveat, one but. Let's write the word but in here.